Factors affecting reaction rate. In any chemical reaction, there are multi-different things that may affect the reaction in multi-different ways. Here, we are going to focus on the factors that affect the reaction rate. But first, to understand what we will talk about, you must understand what is the reaction kinetics. Well, reaction kinetics is the study of the rate of chemical reactions. Reaction rate can vary greatly over a large range of timescales. Some reactions can proceed at explosively fast rate, like the detonation of fireworks, while others can occur at a sluggish rate over many years, like the rusting of wire exposed to the element. There are 4 main factors can affect the reaction rate of a chemical reaction. 1. The nature of reactant. 2. The physical state of reactant and surface area. 3. Temperature. 4. Presence of a catalyst and inhibitors. First, the nature of reaction. The nature of reactants is different from the other factors. And if you ask me why, because it explains the difference in rate of 2 different reactions, but cannot be used to make one reaction go faster or slower. A simple example, when the zinc is dropped into water, a single displacement reaction occurs that produces hydrogen gas zinc hydroxide and heat. If you observe the reaction, you will be able to see the bubbles of hydrogen forming on the zinc, and after a while, you will be able to sense the increase in temperature. In the reaction, the metal is losing an electron or 2. Some energy must be absorbed by the metal to release the electron, and then energy is given off when the electron is added to a hydrogen atom. Second, physical state of the reactant and surface area. The more finely divided the solid is, the faster the reaction happens. A powdered solid has a greater surface area than the single lump. Let me give you an example. In the lab, powdered calcium carbonate reacts much faster with dilute hydrochloric acid than if the same mass was present as a lumps of marble or limestone. The simple explanation for this chemical reaction is, if the particles in the gas or liquid collide with the particles in the solid, increasing the surface area of the solid increases the chance of collision taking place. And increasing the number of collision per second increases the rate of reaction. Third, temperature. Simply, an increase in temperature typically increases the rate of reaction. Increasing the temperature will raise the average kinetic energy of the reactant molecules. Therefore, a greater proportions of molecules will have the minimum energy necessary for an effective collagen. Now, the question that appears in your mind is correct. The rate of chemical reaction can be changed by altering the temperature. And if the temperature is increased, the reactant particles move more quickly. They have more energy. The particles collide successfully more often. The rate of reaction increases. Higher tier only, and this is due to more particles having greater energy or equal to the activation energy. Fourth, presence of catalysts and inhibitors. What are the catalysts? Catalysts are substances that can be added to a reaction to increase the reaction rate without getting consumed in the process. And they usually work by lowering the energy of the transition state, which lowering the activation energy, besides changing the mechanism of the reaction. This has also changed the nature and the energy of the transition state. If you are interested in what type of catalyst, actually it can be wide variety of substances like gases, ions and various complexes, metals and oxides, simple organic compound and complex, synthetic polymers, even water, sand and clay. But the most important factor is the physical state of the catalyst and interacting substances. Catalysts can be either in the same phase as the chemical reactant or in a distinct phase. Catalysts in the same phase are called homogeneous catalysts, while those in different phases are called heterogeneous catalysts. In the opposite side, there is also something called an inhibitors that works in exactly the opposite way as the catalyst. Inhibitors slow the rate of reaction by increasing the activation energy, and sometimes they even stop the reaction completely. To sum up, here are the two pathways for a reaction. The upper pathway is the energy required without a catalyst, while the lower pathway is the energy required with a catalyst. You can see here the activation energy is lower in the presence of the catalyst. So obviously, the reaction is faster. The rate of a chemical reaction is affected by several parameters. Reaction involving two phases proceed more rapidly when there is a greater surface area in contact. If the temperature or reactant concentration increased, the rate of a given reaction generally increases as well. A catalyst can increase the rate of reaction by providing an alternative pathway that causes the activation energy of the reaction to decrease.